Okay, take out your study guide from last night, or your study guide for probability, and we're going to go over your study guide, okay? This is your chance to ask any questions that you may have about probability. Okay, here we go. We're going to start with number 1. Number 1, it says Carrie is going to toss a 6-sided number cube. What is the theoretical probability of rolling a 4? 1 out of 6. Fabulous. I'm so glad that no one said 1 out of 4, because I've had that answer. And I've also had 4 out of 6 today. Okay? 1 out of 6. Why is it 1 out of 6? There's only 1 4 on a 6-sided cube. Okay? All right, number 2. Tom is going to toss a coin. What is the theoretical probability for getting a heads on that coin? 1 out of 2. Good. 1 out of 2. Theoretical, have we done anything yet? Theoretical, is that when you do something or when what you expect to happen? What you expect to happen. Good. All right, next. This problem right here is where I see the most mistakes because you don't read the chart and understand it. Carrie conducted an experiment with a number cube. The table shows the number of times that each number landed. Times landed. Here's the numbers. What do these numbers stand for? The numbers on the number cube, right? The die. So we have a number 1, a number 2, a number 3, a number 4, a number 5, and a number 6. Now this next column stands for what? How many times she landed on that number. Now does that sound like something we've done in here? That was the what are the odds experiment, yes? That's why I made sure we had that experience, because you need to think about that experience when you're reading these charts. You've done this before. All right? Now, how many times did she roll a 1? 8 times. How many times did she roll a 2? How many times did she roll a 3? A 4, a 5, and a 6. How many times did she roll that number cube then?
48.
48. How'd you get that? Yep, you have to add all of this together to get the bottom number. What probability is it when you actually do something? Which probability is that? Theoretical or experimental? So the bottom number for experimental is going to be 48. So what's the experimental for rolling a 1 for her? What will her fraction be? 8 out of 48. What about rolling a 2? 10 out of 48. Rolling a 3. Good. Rolling a 4. Good. Rolling a 5. Good. Rolling a 6. Fabulous. Okay, now switch gears. Theoretical. Theoretical. Before the experiment, what would the theoretical be of rolling a 1? 1 out of 6. Excellent. Rolling a 2. Rolling a 3. Rolling a 4. Rolling a 5. Rolling a 6. These are all theoreticals. That's just your plain old what we know could happen. There's only 1 1 on the cube out of 6 possibilities. There's only 1 2 on the cube out of 6 possibilities. There's only 1 3 on the cube out of 6 possibilities. You follow me? So here's a theoretical, and over here we have our experimental. I'm sorry, I see you can barely see that. Can y'all see that better? Okay. So our question is, this is theoretical. And this over here is our experimental. It's what actually happened when she performed the experiment. Okay, our question is, for which number below did the experimental equal the theoretical? Sounds familiar. When we did the what are the odds, we were looking for a match. Remember that? Did our theoretical match our experimental? Same thing here. We're looking for which number on the number cube do our fractions match. So let's look. 8 out of 48. Can we reduce 8 over 48? By what? By 8. So if we divide top and bottom by 8, we get 1 out of 6. Does the experimental match the theoretical? For what number on the number cube? Number 1. That was letter choice A. I saw a lot of people circled C on that. You will see more of these charts in your work today. And that's why I'm taking the time to be very detailed and explain it. Because you're going to see probably about 6 of them. And you have to understand the chart. You have to understand how to find the theoretical before you start, and then how to get the experimental. Remember, you add all the tosses up to get your bottom number. Okay? Any questions about the charts? No? Okay. Let's now move to number 4. Blake tossed a coin 120 times. The coin landed on heads 40 times. What is the empirical probability? What's empirical mean? It's the same thing as experimental. All right, so what would my fraction be? 40 out of 120. 40 out of 120. Can I reduce that? Now, do y'all know the trick how to reduce if you've got zeros on top and bottom? You know, if I'm reducing this, I can scratch out, I can cancel out a 0 and a 0. Now that brings it down to 4/12. Can I reduce 4/12 by what? 2. I'm going to use 4. It's quicker. 4 divided by 4 is, and 12 divided by 4 is 3. So 1/3. 1 out of every 3 tosses, he will get heads on the coin. That's what that 1/3 means. 1 out of every 3. Okay? Hope you're correcting your study guide as we go along. All right, number 5. Use the data above. So we're using this chart again. What is the experimental probability of tossing a 6? Tossing a 6. Tossing a 6. What's the experimental of tossing a 6? You got to use the chart. What is it? You have to use the chart. Experimental. What will it be? What will my fraction be? I heard it. Who said it? Somebody over here. What will my fraction be? What'd you say, Genesis? Why did you choose 8? Because he tossed a 6 8 times out of 48 total. Somebody said 1/6. 1/6 is the theoretical, and we even labeled that over here. So if you're taking notes on your study guide, you would see that. I even labeled that for you earlier. I didn't ask for theoretical. I asked for experimental. Okay? Can I reduce 8 out of 48? And what will you get? 1/6. It reduces to 1/6. However, I don't think that the intention of the person who said 1/6 was that they meant the 1/6 when it's reduced. They were looking at theoretical. All right, number 6. What is the empirical probability of tossing a 2? That's the same as experimental. So what's the experimental for tossing a 2 then? 10 out of 48. Different color here. So we get 10 out of 48. Can I reduce that? By what? 2, and you get 5 out of 24. 5 out of 24. Number 7. What is the difference between Theoretical probability and experimental probability. We talked about that earlier. What's the difference? Yes, experimental is when we do the experiment. Okay, what's theoretical? Yes. What we expect to happen. You were getting there, Amy. Okay. Do we have that information down? All right. Let's flip over, go to the next page. Okay, it says outcomes. Fundamental counting principles. So we're not doing probability in this next section. Probability are fractions answers. Probability are what kind of answers? Probability requires what kind of answers? Fractions. Probability requires what kind of answers? Probability requires what kind of answers? Probability requires what kind of answers? Probability, probability, probability. Okay, outcomes will be whole numbers. Outcomes, outcomes, outcomes. Okay, I don't want to see any fractions in our next part. Got it? Okay. Number 8. Gabriel is doing a probability experiment. He is tossing a coin and spinning a spinner with 4 equal sections numbered 1 through 4. How many possible outcomes? So when you see outcomes, you're thinking whole numbers, not fractions. All right, so what do I do to figure out the outcomes? I can A, draw a tree diagram, or B, use the fundamental counting principle. Okay, so what are we going to do? 4 times 2. Where does 4 come from? Okay, where does 2 come from? Which gives us 8. Good. Okay, number 9. Dan is going to pick one letter from each bag. How many possible outcomes could be made from the letters? Okay, I can draw a tree diagram, and if I do that, I would first of all start with letter B. And from this second bag, I could pair it with an S. I could pair it with a T. I could pair it with a A. I could pair it with another T, and I could pair it with an E. Then I have to do L next. L, I could pair it with an S, a T, an A, a T, and an E. Now I have to do U next. Want to keep going? No, too long. So how do I do this? What am I going to multiply? Okay, how many letters are here, Osvaldo? 9 times what? 5, which gives us 45. Because if I draw this out, I would count out all those branches on the end. I would get 45 possibilities there. Okay? All right, number 10. Same section. Tony is spinning a 4-colored spinner and tossing a fair coin. How many outcomes? Amy, I heard you say it. What'd you say? 8. What'd you multiply? Which is what? And then the coin is? Good. Number 11. John is rolling a 10-sided number cube, tossing a coin, then spinning a 6-section spinner. How many outcomes? So what am I going to multiply? Let's start at the beginning. 10 times. So we got that. Then he's tossing a coin, so that would be 2. Then spinning a 6-section spinner, so times. Okay, 10 times 2 is, and 20 times 6 is 120. 120 there. Outcomes. All right, number 12. You have 4 shirts, 3 pairs of pants, 5 pairs of shoes, and 3 belts. How many possible outcomes? How did you get that? 4 times 3 is, 12 times 5 is, and 60 times 3 is 180. Excellent. Okay, let's go to part C. So now we're done with fundamental counting principle. Now we're back to probability. What kind of answers do we have for probability? What? 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 Okay, here we go. Shia. Let's start with hers. Here was one of those charts again. Dun, dun, dun. All right. Shia conducted an experiment with a spinner. The results are shown in the table below. What numbers are on the spinner? What numbers are on the spinner? Okay. How many times did she land on a 1? How many times did she land on a 2? How many times did she land on a 3? And how many times did she land on a 4? Okay. Based on this data, how many times can Shia expect to spin a 1 in the next 20 spins? First of all, you have to find out her experimental probability. That's your first step. What is Shia's experimental probability of landing on a 1? Experimental. How many times did she land on a 1? 4 times. Out of what? Not 6. She didn't spin it just 6 times. What? She didn't spin it 20 times, did she? No. We're not even talking about the question. I'm looking up here in the chart. You have to use the chart first. Does this add up to 20? So 4 plus 4 is? 8 plus 6 is? 14. 14 plus 6 is? So she had 20 spins, right? Okay. So 4 out of 20. Now, because I don't want you to use this 20 yet. Don't use this 20 yet. Okay? Now, 4 out of 20 reduces to what? You can reduce it. You don't have to. So what this says is that if she continues to spin this spinner, for every 20 spins, she lands on a 1 4 times. Now, how many more times is she going to do this same experiment? Huh? 20 more times. So I can do 420 plus 420 plus 420 plus 420 plus 420 plus 420 plus 4 over 20 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 plus 4 over 20, and that would be my answer. Or what's the quicker way? Multiply her probability times 20, because she's going to do it 20 more times. What do I put underneath this 20? A 1. Okay, now I'm going to cross cancel here to make this easier for me. And I get 4 over 1, which is 4. Now, if you don't cross cancel, that would be 80 over 20. Cancel out a 0. 8 divided by 2 is 4. Same thing. Woo! So first, find the experimental. Once you get that, multiply it by how many times you're going to perform the experiment. Understand? Okay, let's go to the next question. 14. This one's a tricky one, kind of. John tossed a coin 50 times. He landed on tails 30 times. Based on this data, how many times can he expect to toss? There's a kicker right there. What's it asking about? Heads, not tails, in the next 80 tosses. So what do we know so far? So he tossed it 50. So what's the bottom number going to be on my fraction then? 50. Now we're talking about heads, not tails. Tails is how many times? So what's heads going to be? 20. There's your first fraction. There's your experimental. So for when he spins 50 times, 20 of those times it's going to give him heads. So when he tosses it 50 times, 20 of the times he gets the coin to land on heads. Now, he's going to toss this how many times? 80. So what do I do now? We'll multiply by 80 over 1. Okay? What's 20 times 80? 160. 50 times 1 is 50. Now you have to reduce. You have a calculator. So 160 divide 50. What's that give you? Huh? 35? Huh? 3.2? There's no way. Not for 160 over 50. Oh, hold on a minute. It should be 32. This should be 1,600. My bad. So 1,600 divided by 50. Sorry, y'all. And there's your 32. Because 80 times 20 was 1,600. I missed a 0. Okay? All right, part D. Compound. Compound has how many fractions? 2 or more. And what do we do with those fractions? Multiply them. Okay, here we go. Compound probability. Number 15. What is the probability of landing on a 3 when you spin both spinners? So what's the probability of getting a 3 on the first spinner? Whoops, hold on. Of getting a 3, how many times? 2 over 5. That's our first fraction. Okay, then we want a 3 on the second spinner. 3 over 4. Okay, and what do we get when we multiply 2/5 times 3/4? What do we get? 6 over 20. Can I reduce? By what? And we get 3/10. 3 out of 10. There's a 3 out of 10 chance. Is that going to happen? 3 out of 10? Probably not. Yeah, like 30%. You're right. 30% chance. Okay, next. What is the probability of landing on a 2 on one spinner and a 3 on the other? So what's the probability of landing on a 2 from our first spinner? 2 out of 5. And then landing on a 3. Landing on a 3 for the second spinner? 3 out of 4. Okay, now 3 times 2 is 5 times 4 is, and we can reduce that by 2, and we get 3/10. Any questions? That's your study guide. Okay. I want you to, don't put that up yet. One more thing I want to do with you to refresh your memory. I want you to remember when it says sums, when you see this word right here, you have to draw a chart. What's the sum of 4? The probability of the sum of 4. When you see sum, you have to draw a chart. So I'm going to put 1, 2, 3, 4 across the top. Remember doing this? Yeah. And sum means to do what? It means to add, right? And then down the side, I have to put 1 through 8. Okay? And I'm adding. 1 plus 1 gives me 1 plus 2 gives me 3, 4, 5. I'm looking for 4s. 2 and 1, 3, 2 and 2. Do I need to keep going there? 3 and 1. Okay, don't need to keep going there. 4 and 1. Do I need to keep going anywhere down here? Nope. How many times did I get a 4? 3 times. 3 times out of how many outcomes? This is where we have to use fundamental counting. How many outcomes are here? 4 times how many outcomes are here? 8. And that gives us, so you would get 3 out of 32 for your answer. So when you see the word sum, you got to draw a chart. Okay? Any questions? All right. Put your study guide away, please.